Hey Chloe, Mrs. Vara. These are the problems that were on your quiz that you got wrong. So I just thought I would go through these. Hopefully you can see this. So these are exponentials because your variable is stuck up here as an exponent. That's why we call it an exponential. And your goal in solving these problems is to get the same bases. So the big number we call the base, and then this whole thing here we call the power or the exponent. So I'm just going to show you. If you have something like this, where you have, I'm going to use my marker here, it shows up a little better. You have a base 3. I'm just going to make up an equation here. And then you have something like that. So you have base 3 equal sign base 3. So when your bases match and you have an equal sign in the middle, if you think about it, an equal sign means everything over here is equal to everything on the left side is equal to everything on the right side. The 3's are already equal. 3 equals 3. So it must be true that x plus 2 equals 7. So when your bases are the same, you can set your exponents equal to each other, and then you would just solve this equation, minus 2 from both sides, and you would get x equals 5, right? So the issue here is your bases are not the same. So your goal for both of these problems, 2 and 5, is to get the bases to be the same. So you always want to think, can I rewrite the bigger base? So can I write 8 to have the same base as the smaller base, 4? So think, can I write 8 as 4 to the something? Well, 4 to the 1 is 4. 4 to the 2 is 16. 4 to the 3 is 64. So I can't rewrite 8 as 4 to the something. So when that happens, you want to think, can I rewrite both these bases as a smaller base? So you're always going to a smaller base. If you think about it, I can rewrite both of these as a base 2. So I'm going to rewrite 4 as a base 2, and I'm going to rewrite 8 as a base 2. And I'm putting it in parentheses for a reason so you can see exactly what I'm rewriting. I'll actually use a different color here. So I'm just going to replace the 4. I'm going to keep everything else. And I'm going to write 4 as 2 to the second power, because 2 to the second power is the same as 4. So this is completely equivalent. I've just written it in a different form, but the other form will allow me to solve this problem. So now I'm going to rewrite 8 as 2 to the third power. So this equation and this equation are exactly the same. They're just written in a different form. But now you can see I have the same base. So I can set my exponents equal to each other. But what I want to do before I do that is I have to remember my exponent rules. And my exponent rules say, for example, if you have a power raised to another power, you multiply your exponent. So this would be the same as 2 to the 3 times 4, or 2 to the 12. So I have a power raised to another power, so I need to multiply these two exponents. The other thing you have to be careful about is you're going to do distributive property on this, because you have to multiply the 3 by the 2x and the 3 by the negative 3. You can almost picture it like this: 2 to the 3 times 2x minus 3. So I'm multiplying this 3 by this entire exponent, and 2 to the 2 times x plus 5, because I have to multiply this exponent by this entire exponent. So this is distributive property. So this is going to become 2 to the 6x minus 9 equals 2 to the 2x plus 10. Now my bases are the same, so I can set my exponents equal. I like these problems. I think they're fun. You probably don't think they're fun yet, but you might. Now you want to solve this. So you want all your x's on one side. So subtract 2x from both sides. So I have 4x minus 9 equals 10. Add 9 to both sides. I'm going to run out of room here. I'm going to go to the right then. So I have 4x equals 19. That's weird. This didn't come out as a whole number. Divide by 4. 4 divided by 4 is 1. So x equals 19 over 4. Let me look at this problem, see if it has those funky fractions. All right, where is this one? Oh, well, this one was none of these, so that's helpful. So they did have fractions on there, though. All right, let's look at the other one. And remember, you can check these. If x equals 19 over 4, if you substitute 19 over 4 in here and here for x, simplify everything. You should get the same number on the right and left side of the equal sign. All right, let's try this one. So my bases are not the same. This one, though, I know I can write 25.
Dominic, please come to the north office.
I can write 25 as 5 to the second power. So this is a case where I only have to rewrite the right side of my equation. So now I have 4x minus 5. So 25 is the same as 5 to the second power, so I've just rewritten that. So on the left, I have this. I'm just copying everything on the left. On the right, I have 5 to the 2 times 4x minus 5. Remember, power to a power, I have to multiply. And in this case, that ends up being distributive property. So I have that. And here I have 2 times 4x is 8x. 2 times 5, negative 5 is negative 10. Watch your negatives there. Now my bases match. So I can ignore my bases, set my exponents equal, and solve. So I'm going to minus 3x from both sides because I don't want a negative. So this is going to get me 7 on the left. 8x minus 3x is 5x minus 10. Add 10 to both sides. 17 equals 5x. Divide by 5. 17 over 5 equals x. Let's peek at this problem. Why do they give you these fractions? Just to be tricky. Where is this one? 12 over 5. Did I make a mistake somewhere? Let's go back and look. Well, let me make sure I copied the problem right. Let me check that first. 5 to the 3x. Oh, I copied the problem wrong. All right, let me fix this. Sorry about that. I copied the problem wrong. This should have been plus 2. But you get the idea, right? So if you just go through this, let's do it quickly. Let's change all these to plus 2. So this is going to be plus 2. So this would still be the same, but I'd have a 2 here. So when I add 10 to both sides, over here I would have 12 equals 5x. Divide both sides by 5. 12 over 5 equals x. All right, now let's check that. There we go, 12 over 5. Okay, and then the last one you got wrong is completely different. So this is a log. You're solving a log. Remember, natural log is kind of a special log. It's a log with a base e. So to solve logs, if your x is trapped inside your log, right? I like to say, oh, my x is trapped inside my log. So I need to get rid of this log so I can free my x or bust my x out. The way you do that is you rewrite this as an exponential. Now, when I teach this is how I teach my rewriting. I use this arrow trick, or Sometimes I call it rock and roll. I want to rock and roll. So I'm going to rewrite this as an exponential with a base e. So my first arrow says it's going to be e to the negative 8. And then I put my equal, and what is it going to equal? 3x. So now I can keep solving this for x. If I want x by itself, I'm going to divide both sides by 3. So e to the negative 8 over 3 equals x. This is going to be a decimal. You can put that in your calculator, but let's peek at the answers and see what form they have it in. So they just have it, they keep the e, they don't put it in the calculator. So e to the negative 8 divided by 3 is not listed there, so this was actually a none of these. So that's kind of tricky. So remember on the log, so you got this one right, you need to do the rewrite. Rewrite it as an exponential. All right, hopefully that helps. If not, let me know and we can set up a time to do a Google Meet together and go through some problems.